Happy Monday. This week is dedicated to trig functions of multiple angles. We're going to do sum and difference identities. That's my goal for today. Maybe double angle. And then finish up on Wednesday with the half angle and reduction.
So today is
Sum, difference, and possibly double angle.
Solving trig.
No, just identities.
Oh, okay.
There's going to be some, I think there's some identity verifications using those identities. We're also going to be calculating values.
You know, in music and guitar playing, they have something called a phase shifting effect pedal.
Yeah.
And I guess I'm assuming what it does is takes the wave, matches it and shifts.
Well, there's a branch in mathematics called music theory.
Yeah.
We study the math of music.
Well, there's music of interrelationships of intervals, and then there's the technology of processing the effect signal. But
You need math for that.
phase shifter is one of my favorite effects.
So there's something you can research, look into.
Yeah.
And it's all waves, so it's trigonometric.
Yeah.
There are 6 sum difference well, 6 that we go over. 3 sum, 3 difference. Obviously for the 3 main functions, sine, cosine, and tangents. Although technically you don't need tangent. The identities are derived in the video. All of them are. Oops, I don't want plus, I want minus for this one.
What's the 0 with the vertical slash?
The Greek letter phi.
That stands for?
It's just a letter, just Greek letter. So the theta and phi are the 2 different angles.
Okay, so this pi over 12 is theta? Or
No, it's the angle I'm going to write as a difference.
so pi over 12 is theta minus phi?
Yes.
Okay.
So I'm going to write it as a theta minus a phi.
Okay.
So that we can calculate the exact value. So these are the identities. With the information that we had prior, it would not be possible to find the exact value of, say, sine of pi over 12. Because that's not an angle that we have referenced before. Now we can.
And it's not just half of the sine of pi over 6?
Well, I haven't done the half angle.
No, I'm just wondering, I mean, because we know
No,
pi.
it doesn't work that way.
I'm sure it wouldn't be so lucky.
You could also just do it that way, treat pi over 12 as half of pi over 6 and use the half angle identity.
Oh, forget it.
Right. Same values, they just have different forms. So the idea is to write the angle. In this case, I gave it away, right? Because I'm doing the difference identities as a difference of known angles. That's note. Isn't pi 4 pi minus 3 pi? So pi over 12 can be written as pi over 3 minus pi over 4. And by the way, these identities you may want to keep handy on a separate sheet, right? List of all your identities, just so you're not flipping through pages. This will allow us to write sine of pi over 12 as sine of pi over 3 minus pi over 4. Then using the difference identity for sine. That's sine of pi over 3 times cosine of pi over 4 minus cosine of pi over 3 times sine of pi over 4. We know those values. Well, let me rephrase that. We should know those values. Sine of pi over 3 is what?
That's a 30, 60, 90. Fine. Root 3 over 2.
Cosine of pi over 4. Trig, it's customary to write it as root 2 over 2.
Oh, yeah, true.
It's the same thing. I'd accept it. Remember I said at the beginning, trig is the only time I will actually rationalize the fraction, because that's how it's customarily written. And that's how I have them memorized. Cosine of pi over 3. Well, that was quick.
Water.
That should be one of them. One of them. 1 over 2.
Mhm.
Yeah.
And then sine of pi over 4.
That's root 2 over 2 again. Huh?
Now simplify. Root 6 minus root 2 all over 4. There's sine of pi over 12. Which means leaving your answer as sine of pi over 12 is no longer acceptable, because now you can find the exact value of it. My calc students love me. Cosine of pi over 12. I'm gonna be in prison soon. Got a $15 gift card for Amazon for doing a survey. My wife said she's gonna steal it. She's gonna get shanked. That's okay. We'll still hold classes in my prison cell. So using the cosine difference identity. Cosine of pi over 3 times cosine of pi over 4 plus sine of pi over 3 times sine of pi over 4. Cosine of pi over 3, we already said was a half. Right? Cosine of pi over 4, root 2 over 2. Plus sine of pi over 3, which is root 3 over 2, and then sine of pi over 4 is root 2 over 2. Simplify. Root 6 plus root 2 all over 4. Tangent of pi over 12.
You just go back and throw that big old sine mess over cosine mess, right?
Again, but I'm going to use the identity.
Okay.
All right, just in case, what happens if you're not asked to find sine and cosine first? Tangent of pi over 3 minus tangent pi over 4 all over 1 plus tangent of pi over 3 times tangent pi over 4. What is tangent of pi over 3?
It's root 3.
Tangent of pi over 4.
Two over 2. Wait, no. Oh, no. Tangent. Oh, 1.
Now it's just root 3 times 1. Because I like it to be symmetrical. Root 3 minus 1 over root 3 plus 1. Leave that if you do sine over cosine with what we calculated, that's exactly what you'll get. Wait, why did I write over 2 here for cosine? That should have been over 4. You do get the exact same thing with some algebra.
She thrown root 6 minus root 2 over 4. Root 6 minus root 2 over root 2 plus 6, root 6. I guess you have to rash.
No, just factor out a root 3 or a root 2 from numerator and denominator and cancel out.
Yes.
So you get the exact same thing.
Yeah, okay.
Same question, except now the angle's 5 pi over 12. Through the power of technology, look how quickly I can write this. Identities are the exact same, except you just flip the signs.
Oh.
So every single sign just flips from the difference identity to the sum identity. And vice versa. So if you wanted to, you could just write them as a single identity. Plus minus, plus minus, plus minus, and then do minus plus, plus minus, minus plus, plus minus in that order. That's why typically the sum and difference identities are just classified as one. Idea here, try and write 5 pi over 12 as the sum of two known angles.
The 3 pi and 2 pi. Oh, yeah.
That's just 3 pi plus 2 pi, isn't it? This means we can write 5 pi over 12 as pi over 4 plus pi over 6. Sine of 5 pi over 12 would then be sine of pi over 4 plus pi over 6. That would give us sine of pi over 4 times cosine of pi over 6 plus cosine of pi over 4 times sine of pi over 6. Sine of pi over 4. 2 over 2, we did it already. Cosine of pi over 6.
Root 3.
over,
We're 3/2.
Of course. Yeah, 1, 2, 3, 2.
Cosine of pi over 4 times sine of pi over 6.
So we're looking for sine of pi over 6 now? That's the 1/2, right?
mhm,
Because a sine of 5 pi over 12 is root 6 plus root 2 over 4.
so that's the same as,
Cosine of pi over 12.
just that the.
Which it should be. Oh no, sine of 5 pi over 12 is cosine of pi over 12.
We got. Or root 6 minus.
Yeah, that's for sine. Cosine of pi over
Oh.
12. It should because that's the cofunction identity, isn't it? Pi over 6. Isn't that pi over 2 minus 5 pi over 12? That's the cofunction identity. Because then we wouldn't be using the sum difference identities. The fun is figuring it out for yourself. Cosine of 5 pi over 12 would be cosine pi over 4 plus pi over 6. That is cosine of pi over 4 times cosine pi over 6 minus sine pi over 4 times sine pi over 6. And of course, we already have these values. And you simplify root 6 minus root 2 all over 4. Tangent would give us tangent of pi over 4 plus pi over 6. Tangent of pi over 4, we already did. Tangent of pi over 6. Factoring 1 over root 3 out from both the numerator and the denominator. All right, they're obviously going to cancel out with each other. What are you going to be left with in the numerator? If you factor out a 1 over root 3.
Root 3 plus 1.
What about the denominator?
3 minus 1.
Does that satisfy the cofunction identity for tangent? Right, 5 pi over 12 is pi over 2 minus pi over 12. Which means tangent of 5 pi over 12 should be cotangent of pi over 12. Is it?
Oh, wait. Repeat that.
So cofunction identity for tangent. Tangent of pi over 2 minus theta is cotangent of theta. Well, 5 pi over 12, pi over 2 minus pi over 12.
7 pi. Wait, pi.
Pi over 2 minus pi over 12 is 5 pi over 12.
Pi over 2 minus 5 pi over.
No, pi over 12
Oh, minus pi over 12.
is 5 pi over 12, right? 6 pi minus pi.
Oh, right, yeah.
That means that tangent of 5 pi over 12 has to equal cotangent of pi over 12. Does it? What's tangent of pi over 12? So what's cotangent of pi over 12?
Flip the reciprocal.
What do you mean by opposite?
For root 3 plus 1 over square root 3 minus 1.
Isn't that what we have for tangent of 5 pi over 12?
See.
No comprende. I know. Habla matemática. Don't say I only speak math, so I'll just go with that. I can actually cheat on resumes and say I'm bilingual. Speak English and math.
Sure.
All right, so cofunction identity is satisfied. Perfect. If it wasn't, we'd be in trouble. That means something went wrong. Oh, by the way, with these identities, you can now prove the cofunction identities analytically instead of geometrically. We want to write each of the following expressions in terms of trigonometric functions of a single angle. Sine alpha plus beta plus sine alpha minus beta. I'll use the sine sum identity. to rewrite sine of alpha plus beta. What do you get?
Oh. And plus. So it'd be sine alpha times cosine phi, or I'm sorry, sine alpha times cosine b
No, dude, it's not a B.
of beta.
The Greeks would be very upset with you.
Plus cosine alpha sine beta.
That?
Uh, yeah. Yeah. Plus, well, that's the first part. And then. Other one will be the same, just with a minus in the middle, right? Same pieces.
Here's another beautiful thing about doing it on technology. If it's too long for one line, I can just move it.
So the second parts will cancel each other out, right?
Can you tell me, really?
Yeah, well, you got a plus cosine alpha sine beta and minus cosine alpha, so it'll end up just being 2 sine alpha cosine beta.
There's your function. By the way, this is an identity. Maybe a useful one. Here's another identity. Again, use the sum difference identities. Rewrite cosine of alpha plus beta. What is it?
Cosine cosine plus sine sine.
Said plus.
Oh, a minus, whoops, wait a minute, the plus, the parentheses plus. Wait, the addition identity for cosine. Did I write it wrong? Isn't it cosine beta, cosine phi? Oh, it's minus, whoops, oh, okay.
Cosine's the opposite. Difference identity, isn't it the same except the sign flips?
Right.
-2 sine alpha sine beta.
See.
So how are we going to rewrite this? And this is why I get paid the big bucks.
Right, is 10A plus 10 alpha plus.
Identities work in both directions. What we have is the difference identity for tangent of two angles. So that would just be tangent of alpha plus beta minus alpha. Which is just tangent of beta. It will be left to you to verify that if you go the route that Chris was trying to go, and using the sum identity replace tangent of alpha plus beta, after quite a bit of algebra, you're left with tangent of beta.
Wait, that's the top, that's the numerator.
You also have a tangent of alpha plus beta in the denominator. So you'd have to replace it in both and then simplify.
Can you do that a little more detailed in a second? Yeah.
Replace both of those with tangent of alpha plus tangent of beta all over 1 minus tangent alpha times tangent beta. That's the sum identity for tangent.
Right, but
And then you have to do algebra to simplify it. And you'll get tangent of beta.
no, I believe you, but I'm still not understanding here what happened to the denominator. Like, I see that we say, you know, I guess the rule is tangent of X minus tangent of Y is equal to tangent of X minus Y. It's not. Then,
Tangent of X minus tangent of, or tangent of X minus Y is tangent of X minus tangent of Y all over 1 plus tangent X times tangent Y. Which is exactly that. They gave us this side. I wrote it as this side. Where theta is alpha minus beta. I'm sorry. No, they did plus, right? Yeah, alpha plus beta. I'm sorry, I said alpha minus beta. Alpha plus beta. Right, and phi is just alpha. Right, so that is how I got this. They work in both directions. By the way, that also means I can now do something like this. And so you evaluate that. That's sine of pi over 6, which is a half. Right, because that's the sum identity for sine. So we can now go both directions. Sine of alpha cosine of beta minus cosine of alpha sine of beta all squared plus cosine of alpha cosine of beta plus sine of alpha sine of beta all squared. Well, that just looks hideous. Now you have two binomial theorems.
Yeah, but you have identities for this. And put it back into. Like. We're gonna get this back into something with. A plus, the alpha plus beta in parentheses again, right? Like quantity alpha plus beta.
You tell me, is that what we're gonna get?
Well, like the first one, right? Sine, cosine, minus cosine, sine. Sine, cosine, minus cosine, sine. That's the sine, the difference identity.
Right?
So that would just be, that first parenthesis would be sine of alpha minus beta,
Right?
sine squared.
Right?
Oh.
But why would we want to do that? When the instructions said to write it as a single angle.
Well, it will be a single angle. It's just a value expressed as a difference of two.
That's not what we want. Otherwise, I would have left it like this.
Oh,
Right? Each trig needs to be of just one angle.
oh, well then, so that maybe that's the first step. You could get it, no, well. Wait a minute. That's sine squared. The other one. It doesn't matter what the angle's gonna be. It's gonna be a sine squared, blah, plus cosine squared, blah. And that
Are they
always
the
equals
same
one,
angle?
right? Well, it's gonna be,
It only equals one if you're taking the sine and cosine of the exact same angle. Otherwise, no, it's not one. Right? So for instance, sine squared of x plus cosine squared of y is not one.
well, of course, yeah, but it's the angle expressed as a difference of
Right.
two things.
So are the angles going to be the same? That's what I'm asking. Right, you said the first one's going to be sine squared of alpha minus beta, right?
Yeah. And the other one would be
Cosine
cosine
squared
squared
of,
of alpha minus beta.
that's why you want to go that route.
Yeah.
This breaks down to Pythagoras. That one was.
I just had I have to retake a test later, but I just have an emergency, so can I do it on Wednesday? Sorry, I have some drill. Oh, gosh.
You too. Good luck with
Yeah,
everything.
good luck.
Thanks.
Well,
What we want to do is find sine and cosine of both alpha plus beta and alpha minus beta, as well as the quadrant that those two angles are located in, using the given information. And so here we're told that sine of alpha is 4/5, cosine of beta is 5/13, and both alpha and beta are in quadrant 1. Well, alpha and beta are both in quadrant 1, meaning they're acute angles. So right triangle trigonometry of both of them.
They have to both be in this, they don't, no, they don't have to both be in the same quadrant to do these type of problems.
No, and this problem just tells us that they're both in the same quadrant.
Oh, it actually, oh, I thought you determined.
No, it tells us
Oh.
alpha, beta, both in quad 1.
Okay.
Look at the alpha triangle. Now I'm making it sound like they're in packs. What sides do we know? What leg?
Opposite.
What's the opposite?
There's your 4. There's your 5.
So what is the missing leg?
3.
What about the beta?
Certainly not drawn to scale.
Nope, never assume drawn to scale.
So your adjacent, your bottom, base of the triangle, as it were, there's the 5. The diagonal's 13.
No dear, you called it diagonal.
The hypotenuse.
No dear. That's like an automatic F. What's the missing length?
Deceptively drawn 12.
That's why you never assume the scale. Start with alpha plus beta. Sine of alpha plus beta. What's the identity?
Sine, cosine plus cosine sine.
Sine of what, cosine of what?
Well, sine alpha cosine beta plus cosine alpha sine beta. Or vice versa in this case.
Sine of alpha. Oh dear.
4/5.
Yeah, it's given to us. Cosine of beta. What's cosine of alpha? What is sine of beta?
I guess better not cancel that one out.
Twenty over 65 plus 36 over 65, right? $56 over 65. And of course, make sure that that doesn't violate the most important rule. sign has to be between between -1 and +1. If you ever calculate a sign that is larger than +1 or smaller than -1, you've done it wrong. For things like that, generally I will award you 0 credit. Because that's something you should immediately identify as you did something wrong. So go back and check. Cosine of alpha plus beta. What's the identity?
Cosine, cosine, minus sine, sine.
And we already have those values now, don't we? Oops. Three-fifths times 5/13 minus 4/5 times 12/13. 15/65 minus 48/65. -33/65. Use that information. What quadrant is alpha plus beta in?
Cosine's negative. That be the second?
And if you actually just examine it and think logically about it, you would know it has to be quadrant 2.
Now,
If
wait a second.
if you add 2 quadrant 1 angles, it can't be in any quadrant other than 2.
But
Oh, I'm sorry. No, it can be actually.
they
I
said
lied.
it was quadrant 1.
No, alpha and beta are quadrant 1.
Oh, so the
Alpha
the
plus
function of
beta
the
is
sine.
quadrant 2.
Yeah, why couldn't they both be like 30-degree angles?
They could both be in quadrant 1, yes, but they can't be they can't be outside of quadrant any larger than
Beyond
quadrant 2.
quadrant.
Right. Sum of 2 acute angles could still be acute or obtuse.
What's a reflex angle again? Is that more than 180? Is there something called a reflex angle? No, I'm reading that phrase just popped into my head. Google that.
I'm not good with geometry, so.
Ah. Yeah. Thank God. The last time I heard that was 40 years ago.
Maybe it's an angle that slaps you in the face out of reflex. All right, let's do the difference. Sine of alpha minus beta. So what would the identity be?
Sine alpha, cosine alpha, yeah, sine alpha, cosine beta. minus cosine alpha sine beta.
Now, of course, we have all this. Oops, I don't need. I can just bring this down and turn that plus into a minus. The 20 over 65 minus 36 over 65. Negative 16 over 65. The identity for cosine alpha minus beta.
Minus, cosine minus sine sine.
Said minus.
Yeah.
Hmm. Notice what you just said. You just said cosine of alpha plus beta equals cosine of alpha minus beta. Which is not necessarily true.
Oh. As you know what, yeah, of course not. That's the sum. It's oh yeah, plus. Ooh.
And so what I have to do is take what we did above for cosine of alpha plus beta and change the minus into a plus. 15 over 65 plus 48 over 65. 63 over 65. Both are between -1 and +1, so that's good. We did the arithmetic correctly, at least. What quadrant does that make alpha minus beta in? So in quadrant 4. I like these types of questions. They test your knowledge of all trig. Sine of alpha is 2/3, cosine of beta is 3/4. We're told alpha's in the second quadrant, beta is in the fourth. Perfectly straight. No, not drawn to scale. Uh-oh, that's not what I meant to do. I can get away with the origin. There we go. So let's say there's our alpha angle. So for that graph, what do we know?
I'm sorry, what do we know about what?
What do we know about this graph?
You know, I mean, wait, you talking about filling in lengths?
Mhm.
So the hypotenuse is 3
Well,
and
it's not really a hypotenuse.
diagonal? The ray emanating from the origin, yeah, that thing, and then the vertical is 2.
What does that make this?
5. Negative root 5. I've always been,
That's why I said they're
Very-
not lengths.
say again?
That's why I said they're not lengths.
Yeah, I know. I almost made a big mistake on the test with that. But I-
This point here is the point negative root 5, 2.
Yeah,
Right, so I'm just letting this represent the x coordinate. There's the angle beta. And so what do we know for the beta graph?
Well, you know that
Uh-oh. I didn't click on you, go away.
your horizontal length is gonna be, 3. The, diagonal is 4. So the other one's gotta be negative root 7.
Sine of alpha plus beta. We were told sine of alpha and cosine of beta. What is cosine alpha?
Five over 3.
What is sine of beta?
Negative root 7 over 4.
We're going to get 6 over 12 plus 35 over 12. Six plus root 35 all over 12. Let's ask this question now because we're going to need it. Is that positive?
Either way, it's positive.
What do you mean either way it's positive?
Well, root 35 is just a touch under 6 or above negative 6.
Well, I mean, technically speaking, if you're touch over 6, then you're above negative 6.
Yeah, well, what I'm saying is that either plus or minus root 35 is still gonna be above 0 if you add it to 6.
Root 35 can't be negative.
Oh. Well. Why not?
What's the square root of 4?
Positive or negative 2? Okay, it's just default positive.
Yes.
Okay.
When you take the square root, it's always the positive square root. The reason what you're thinking when you do the square root of x squared is absolute value of x.
Yeah, which is all these kids I'm tutoring.
It's because x is an unknown. Right?
Oh.
If you take 2 squared and the square root of that versus negative 2 squared and the square root of that, they're the same. They're both 2, but x are different values.
Right, okay.
That's why.
Right.
So the square root is always the positive. So that's obviously positive, right? It's a positive plus a positive divided by positive. Perfect. Cosine of alpha plus beta.
No, wait, hold on a sec, back up. Why is it so important that that was greater than 0?
Oh, it's not. It's just we need it. Because remember, we have to determine the quadrant that alpha plus beta is in.
Oh, I see, so sine is positive, okay, so.
All right, we have cosine alpha, cosine beta. Then we have sine alpha times sine of beta. We already know that sine alpha and sine beta. Two root 7 minus 3 root 5 all over 12. Is that positive or negative?
We use a calculator.
We shouldn't need one.
Oh. All right, I don't have my non-perfect square roots over on it.
You don't really need to have them memorized.
You're telling me that you really don't need a calculator or memorization on this? You got me. Seven, so it's gonna be negative. But how did you?
Root 7 and root 5 don't differ by that much.
Well, I know, but
So they're approximately the same.
well, that's a big approximation.
Well, when I'm dealing with 2 and 3, it doesn't matter. Because
Okay.
they don't differ by that much. 3 is larger than 2, therefore that's negative.
Right. So the sign is negative. So you're in the second one.
Right. The point is both root 7 and root 5 are between 2 and 3.
Yeah.
That's why I just say they're about the same. So they're
Right.
both going to be a value between 2 and 3. That decimal difference doesn't make that much of a difference when you multiply by 2 versus 3. So you can just go, it's about 2 times x minus 3 times x, which is negative. And I'm done. I wouldn't have been able to do that if that was like root 11. Because now they're not in the same ballpark. So where are we located? Quadrant 3. You shouldn't be guessing. The answer's staring you right in the face.
Negative.
Right, but what sign? All right, so what quadrant is that?
So it's in quadrant, 4. Well, x. Quadrant 2.
It's quadrant 2. Sine is y, cosine is x. X is negative, y is positive. That's quadrant 2. probably the only thing from geometry I'm good with. Sine of alpha minus beta. Again, not much we need to worry about. I can just copy and paste and change a sign. Sine of alpha minus beta will wind up being 6 minus root 35 all over 12. Is that going to be positive or negative? Just positive. It's just barely positive. But this is either horseshoes or hand grenades because that's the only time that close counts. Cosine of alpha minus beta.
Just be root 7 plus. Yeah.
Right, the signs just flip. Or do they? I have here that they don't. Oh, right. I'm sorry. No. Only that sign flips. Yep, that makes, yep. Because the value of cosine alpha, cosine beta doesn't change. So that second sign flips from plus to minus.
Oh. Oh, so it looked weird because you had written it as 2 root 7 minus 3 root 5, but if we left it as negative 3 root 5
Right.
plus 7, then it would have been negative 3 root 5 minus 2 root 7,
And that's,
which is, yeah. Yeah.
yeah. Is that positive or negative?
It's gonna be negative.
What quadrant are we in? Caitlin redemption. Oh dear.
3.
Oh dear. Redemption failed. I tried.
3.
It's not 3.
That's what I said originally.
No, it's not. Well, yeah, the first time, but that was also wrong.
That's what you meant. All right, hold on. It's a negative, so it's gonna be in 2.
Quadrant 2. Oh, they're both in the same quadrant. Some difference identities. Questions. Getting there now. We can have some real fun with trig. Means that on Wednesday, we'll do double angle, half angle, and reduction, I think.